Hello everyone and welcome. My name is Mohammed El Shawabka and this is my project demo for in-cabin monitoring system. Here we have the first step of the project, which is teaching the algorithm using deep learning a set of figures for three categories or three states for the driver. And then uploading or deploying the code into the hardware, which is in this case a Raspberry computer. Starting from the first file here, which is the transfer learning code. In this file, the algorithm will be changed in order to have only three outputs, which is the three states or three monitoring states of the driver from the pictures. This code or this transfer learning code is based on an example from MathWorks from the convolutional network called AlexNet, and this network is trained to have 1,000 outputs. In my case, I have to change it in order to get only three and retrain it on the new dataset I have or prepared. In this case, once we prepare the files or the pictures, as we can see here, we have three categories. I call them drinking, focused, and using phone, where the driver, for instance, is drinking using cup, and the second categories, like for instance here, there are different pictures from an online free dataset, and I use 60 pictures for each category or for each state. This is for the drinking, and we have for the focused, where the driver is focusing in the forward, and here we have the last one is using phone, as we can see, and so on. So here we have the three pictures. The pictures, the original pictures are larger than this. I cropped them and resized them to be 227 pixels squared for each picture, so that the algorithm can deal with them. And now, once these pictures are prepared, here we need to get only three instead of 1,000 output or 1,000 pictures, since this AlexNet algorithm distinguishes between 1,000 items. In our case, in this case, only three. And here we define the folder of these new driver images, as we can see here. Once this step is done, we take 90% of these pictures from each category for training and the remaining 10% for testing the algorithm, as we can see. Now, after retraining this algorithm, what we have here is the data of the trained model is saved in Minet file, as we can see here, and it's already trained, and we have the file here, Minet, so that later it's saved and used in order to generate the code. Here I save it in a new name. The next step, once we get the file or the trained file according to the new pictures we have, we go to the function or the main function that's going to be converted into C+ code and deployed on the hardware we have. So here the hardware is Raspberry, connect over Ethernet cable. We have its IP address and its login credentials. Now this is the same my net file. I save it as math function with another name, so that it's in the same directory here. And then and then I use continuous scanning in a while loop in order to keep scanning each frame every 1 second, so that the hardware can deal with it, the Raspberry hardware, instead of live live checking, so that um, can handle the pictures due to the limitation and the processing power of that small computer, the Raspberry. Now, here what do we have? We take a screenshot every time and we scan it. And according to the classification result, we have different scores for everyone. But what we care here is about the label that's used in training these images. From these images, we have 3 labels here using food, phone, focused, and drinking. Now, since we have 3 labels, here I create small box in the corner of the generated picture, so that we can distinguish. It's red when the driver is drinking or using phone, and green in case of driver is focused. And then we construct this image with its label according to the classification result, and finally we display it on the screen with these values and the score of the live image comparing with the accuracy or the original trained image. Now this is the function that's going to be deployed to the hardware. Now, in order to do this process, here we have the code generating process here, and the hardware is going to be Raspberry. The Matlab code is going to be converted or generated as into C+ code, and here we have the configuration for the deep learning algorithm and the hardware that's going to be used. And here we have the function that's going to be deployed, which is the same name function here, to the Raspberry. Now, by running this file, and making sure the Ethernet cable is connected to the hardware, then it starts generating this code or this function into C+ code, and then saved on the Raspberry board to be run in the next step. So here running the code generation process. Well, now it starts generating the code. This process will take some time, and then once we have the code already deployed on the Raspberry, we will switch to the Raspberry and discuss the how to run it from there, and as a standalone without using the Matlab C+ code. Now the code generation process is done. As we can see here, it's already deployed on to the Raspberry, and here we have the report of this process. Now this is our function here, as we can see. This is the same Matlab function that's going to be deployed, but in this case it's converted into C+ code, and here we can see the source files and the libraries that are required from Matlab in order to do this process. Everything is converted into C++ and deployed. The next step is going to be running the main Matlab file here in order to let's say in order to make the image processing standalone from the Raspberry. And in order to do this, we are going to do we are going to use the VNC in order to access the Raspberry from its IP address, and then we will run this main here the C+ code so that we have the result. Now in the last step, I'm going to run the generated code, C code on the Raspberry without using external screen or keyboard. We can directly do this using VNC over an Ethernet cable. So here we have the VNC and just access the Raspberry, and here we have its desktop. From here, we can follow the same directory of the files from the Matlab. We'll find the same here in the Raspberry. So here we have the same directory. And this is the file that we are interested in order to run it, because it's already executable file. Here, since we are on the same directory, we can do this from the terminal. And run. We are waiting for the camera preview. It has a refreshing rate of 1 second. And I will be testing the 3 scenarios. Here I'm doing it on my disk. Since I'm already focused in front of the screen, we can see the status is focused. And if I use my phone, we can see it's red and says using phone. I will be switching to the last state, which is drinking. Switching between them.